Now that you've finished your discovery activity, you should have the formula for the law of sines. It is important to know that you cannot use the law of sines for every single triangle. You have to be given certain scenarios that will allow you to use the law of sines. These are the two cases that allow you to use the law of sines. You can be given two known sides of a triangle and one known angle, but it has to be opposite of one of those known sides. So that's three pieces of information, two sides and one angle, but the angle has to be opposite one of the sides given. The other case is to know two of your angles, and then you can know any of your sides. The key here to both of these is you must have an opposite angle and side pair to use the law of sines. So here, we're given it when it says one of the sides is opposite this angle. Here, since we're given two of our angles, we know we can use the Triangle Sum Theorem to find the third one. We know we can just add the two that are given and subtract from 180, and now we know all three angles. So when we're given one side, we know we now have an opposite angle and side pair. So that's the key. To use the law of sines, you have to have an opposite angle and side pair. I'm going to have to focus here. It's really blurry. So in just a moment, let's get that focused in. Okay, maybe that's a little better. All right, so here is the law of sines that you should have discovered in your discovery activity. Again, it doesn't matter if you have the sign of the angles in the numerator and your side lengths in the denominator, or if you have them all reversed. But you have to have they have to be in the same place. You have to have your signs all in the numerator or all in the denominator, and your sides all in the denominator or all in the numerator. You can't switch them in a proportion. So for instance, I could not write sine of A over A equals B over sine of B. That would be incorrect. Either the signs have to both be in the numerator or both in the denominator. So that would be wrong. But either of these is fine. Now in the formula, you have three ratios set equal to each other. When we're solving, we're only going to be using two at a time. So we would be using these two, or these two, or these two. You would never use all three at one time. Another thing to be careful about is, remember, these are capital A's because we're taking signs of angles, and angles are always named with capital letters. These are lowercase letters because they're representing the side lengths. So lowercase for side lengths and uppercase for angles. Okay, so let's look at some examples here. Our very first example gives us the measure of angle A. It gives us side A, side B, and it just tells us to solve. Well, on this one, I'm going to ask you to find the measure of angle B. That's going to be our goal. So remember, to use the law of sines, we have to know an opposite angle and side pair. We know that when we're given angle A and side A. There's my opposite angle and side pair. So when I'm deciding out of my formula what ratios to use for my proportion, I'm definitely going to be using the sine of A and side A because that's the opposite pair that I'm given. So I'm going to go ahead and write sine of A over A. Remember, you could do A over sine of A. That's fine too. You just have to be consistent. Now, I'm writing a proportion, so I have to have that set equal to another ratio. Since I'm finding angle B, my other ratio is going to be the one that involves the B's. So I'm going to write sine of B over B. I don't care about my C's at all, so I'm not going to include the sine of C over C. So now I'm going to fill in the information I know. I know angle A is 67, so I'm going to write that as sine of 67. I know side A is 14, so I'm going to replace that with 14. I don't know angle B, so I'm going to keep that as sine of B. But I do know side B. I know it's 9. So now I only have one unknown in my equation, and that's what I'm going to be solving for. So since I have a proportion, the first thing I can do to solve is cross multiply. Multiply the numbers across from each other. Now, when you multiply sine of 67 times 9, you're not multiplying the 67 and the 9. This 67 is having the sign taken of it. So when I multiply 9 times sine of 67, I'm going to put the 9 in front as a coefficient. I'm not going to write it behind the 67. When I multiply 14 times the sine of b, again, I'm going to put the 14 in front like it's a coefficient. Now, I don't have b by itself. The first thing I'm going to do is get sine of b by itself by getting rid of the 14. I know I would be undoing multiplication between the 14 and sine of b, so to undo multiplication, I'm going to use division. I'm going to divide by 14 to get rid of that 14. Now, I know I have to do the same thing to the other side, so I'm going to divide it by 14 as well. So now I have sine of b by itself. It is 9 sine of 67 divided by 14. But that doesn't tell me what b is. Remember, to get b by itself, I need to undo the sine of b. And so the inverse operation for sine, if you'll remember, is inverse sine. It's this sign with a -1 power on your calculator. So to find the measure of angle B, I'm going to be taking the inverse sine of both sides. When I take the inverse sine of this side, it takes away that sine and just leaves me with whatever the measure of angle B is. But I also have to take the inverse sine of this entire side over here, the 9 sine of 67 divided by 14. Notice I put it in parentheses. I'm taking the inverse sine of that entire thing. So I'm going to do that on my calculator. Make yourself a little note here. Don't forget, you need to make sure that you're in degree mode. So on my calculator, the first thing I'm going to do is I'm going to go to mode and make sure that degree is highlighted. If not, you'll scroll down and to the right and press enter. Then you can hit second mode to get out of that. And now I can type in what I need to find the measure of angle B with. So when I press inverse sine, I have to press the second key and sine to bring up inverse sine. It opens up the parentheses for me to put everything in there that I'm taking the inverse sine of. I can go ahead and type 9 sine, but you remember it opens up parentheses again, so I'm going to put in the 67, but then I've got to close parentheses because that's all I'm taking the sine of. And then I can press divided by 14 and close my parentheses of what I'm taking the inverse sine of. So this closes that parentheses. This just closes the one for the 67. So I'm going to press enter, and we're going to be rounding to the nearest tenth, so that 2 will become a 3 because of the 8 next to it. So the measure of angle B is approximately, we're rounding, 36.3 degrees. So we did exactly what I asked you to do, which is find the measure of angle B. So this one, and remember, is a rounded answer. It's approximately 36.3. If I wanted to find the measure of angle C, I could do that now using the Triangle Sum Theorem, adding these two together. Subtracting from 180 would give me C, angle C. If I wanted to find side C, I'd have to use my law of sines again. I would go back to using sine of A over A, but then I would use the sine of C over C as my second ratio. I would have found C using my Triangle Sum Theorem, so I could solve for C. Since I know these two and that, I would solve for C then. Okay, let's look at our second example. This is that second case here where we know 2 known angles and 1 known side. But remember, we need an opposite angle and side pair to use this law of sines. I know side A, but I don't know angle A. I know angle B, but I don't know side B. I know angle C, but I don't know side C. So I can't use law of sines yet till I have an opposite side and angle pair. Well, since I'm given 2 of the angles, I can find the measure of angle A using the Triangle Sum Theorem. All I need to do is add the 63 and 38 together for the 2 angles I'm given, and subtract that from 180 to get the missing angle to be 74 degrees. So I know the measure of angle A has to be 74 since those 3 have to add up to get 180. Oops, just noticing I did in 68 instead of 63, so let's do that again. 63 plus 38, and subtract that from 180 gives me 79 degrees, not 74 degrees. My bad. Now I have an opposite angle and side pair, so I can use the law of sines. I'm going to use my A's again as one of my ratios. My second ratio depends on what I want to find. It just said solve, so we can pick which one we want to find. Let's find side C. So I'm going to tell us up here, find AB. If it asks you to find AB, well, AB is side C. So that's the same thing as my C value. So for my second ratio, I'm going to do sine of C over C. So now I'm going to put in the information that I know. I know angle A is 79 degrees, so I'm going to have sine of 79. I know side A is 15, so I'm going to put that over 15. And equals, I know angle C is 38, so I have sine of 38. But I don't know side C, so I'm going to leave that as C. So in our first example, we were missing an angle. On this one, we're missing a side. But we solve it exactly the same way. We're going to start off by cross multiplying. Remember, when I multiply by the sign of something, that number is going to go in front as a coefficient. So C sine of 79 equals 15 sine of 38. So to get C by itself, all I have to do is undo this multiplication and divide by sine of 79. I'm not going to have to worry about the inverse function because I'm not solving for an angle this time. We only use inverse trig when solving for an angle. So we're going to divide by sine of 79 on both sides. So this sine of 79 and this sine of 79 cancel. So my C is equal to whatever 15 sine of 38 divided by sine of 79 is. I'm already in degree mode, so I can just enter that into my calculator. You don't have to worry about extra parentheses here because your calculator will do multiplication before division anyway. So you can just go straight into 15 sine. Now notice your calculator opens up parentheses for what you're taking the sine of, which is 38. So make sure you close that parentheses before dividing by sine of 79. Now it really doesn't matter to your calculator if you close that one or not since it's at the end. So you can't see that, there was a glare. But it really doesn't matter if I close that parentheses or not. I'm OCD, so I just like to close my parentheses. But then I can press enter and round to the nearest tenth. So C is approximately 9.4. It doesn't give me units, so it's just 9.4 is what our C is. Now remember, we could have found B too. We would still use the A's since those are given and not rounded answers. I wouldn't want to use these opposite pairs if I can keep from it, because C is rounded, okay? But I can use my A's to find the B. I would do the same thing, but here I have sine of B over B. So hopefully that makes sense. You might want to watch this again if you need some more examples to watch.